guys, how's it going today? Today's lesson is over the anatomy of a wave. One of the things that we need to make sure everybody understands is that waves are all around us. There are thousands of waves out in the universe. But the neat part about waves is that if you understand one wave, you understand them all because they follow the same rules, the same guidelines, the same laws, and they all have the same parts. So when we talk about a wave in water or a hand waving or sound waves or light waves, the neat part is that they're all the same. They're similar, which means we can talk about one and now you know everything there is to know about all waves in the world. So we're going to go through some terms here that you'll need to know for the upcoming labs that we have. For you at home learners, it's going to be a little harder to figure out the labs. I should hopefully have something for you, but we'll get there from there. So we're talking about the anatomy of a wave. The first part, of course, is what causes a wave to form? Well, let's check out the relationship between a wave, or between the energy of a wave and the motion that it has. And we're going to use a tuning fork and water to do this. So I'm going to have a demonstration for you that shows you that energy to motion relationship. Okay guys, we're going to talk about waves and the energy that takes place. So what we're going to use is a tuning fork. Now, a tuning fork is a device that creates sound. You should be able to hear it. And how does it create that sound? Well, it creates the sound that when I smack this on my hand, these tines vibrate back and forth. As they vibrate back and forth, they move the air, creating sound in our ears. We can amplify this just a little bit, where this box will actually amplify that sound for you. But it's hard to see that those things are actually moving back and forth. Can you see them vibrating? And the answer is no, not really. We can't see them vibrating. So is there a way that we can show you that these are vibrating? And yes, there's energy in here. And I can transfer that energy to the water. Do you see the water fly? We can do it with all sorts of tuning forks. Here's a different one. It's a little bigger and heavier. And you can see that the water moves. Well, the only way the water can move is if the tuning fork is moving. For instance, if I don't hit it, and I just put it in the water doesn't move. But if I hit this, they're moving back and forth, and you can see the water fly. That's how we know that energy is being transferred. So as we go on with this stuff, we're going to talk about the parts of a wave. But at least you can see that there's energy in there and that waves are in motion. This is kinetic energy. All right, be right back. Okay, now that you saw that, which is kind of cool, that you can see that that tuning fork is moving and that it has energy and that energy relates to actual motion of the water, let's talk about the words that we have. We have 7 words that you need to know about. The first one is crest, trough, amplitude, wavelength, period, frequency, and node. Those are the words that we're going to have. For some reason, this one messed up. It should be, some people call it trough, some people say trough. It's okay either way. Not what a pig eats at. Not trough like that. This is a little different. So we're going to go through and we're going to label these on the wave diagram for you. We have 7. Crest, trough, amplitude, wavelength, period, frequency, and node. All right, so here is our wave that we have. So we can label each one of these. The first one is crest, not the toothpaste. A crest is actually the topmost part of the wave. This is a crest. This is a crest. So the highest point of the wave, that's a crest. Which leads us to the lowest point of the wave, of course, is the trough. All right? Highest point crest, lowest point trough. Remember this line in the middle is equilibrium. That was from the last lesson. I'll put it in here for you. That's equilibrium. Now, so we have crest, we have trough. Wavelength, amplitude, wavelength, and period. All right, the amplitude. The amplitude is relatively simple. You start on the equilibrium line, and you measure to the highest point. You measure to the crest. This is amplitude. All right. You can also measure it from equilibrium to the lowest point. That is amplitude also. Amplitude, guys, is simply how loud something is. The taller the wave, the louder it is, the brighter it is, the more force and energy it has. So amplitude has to do with the amount of energy that a wave has. The taller or the higher, the bigger number amplitude is, the more powerful the wave. So you would measure that from there. That is a amplitude, all right? Next term is wavelength. A wavelength, simply put, is one up, one down. So if I'm measuring this, my wavelength is going to be from here, one up, one down, return to start, to here. This distance is a wavelength. So on this diagram, I have 1.5 waves. Here's one, here's the half. Start at equilibrium, one up, one down, wavelength. Make sure I got all the words. Start with a node. A node is any point where the line, where the wave crosses equilibrium. So anywhere the wave crosses equilibrium, oh look, it crosses it right here, that's a node. Oh look, it crosses right here, that's a node. It crosses right here, that's a node. It crosses right here, that's a node. So a node is any place the wave crosses equilibrium. All right, so we've got these up. I am going to erase these for the next two, all right? I am going to erase these, well, maybe erase these, yep, for the next two. All right. If the word that we're looking for is period. A period is the time it takes for one wave. For instance, let's say 1 second, 2 seconds, 3 seconds. The question is, what is the period of this wave? Well, it's the time it takes for one wave to go by. One up, one down, right here. The period of this wave is 2 seconds. Remember, one wave is one up, one down. Check the time, 2 seconds. The frequency, on the other hand, the frequency is how many waves pass in 1 second. So in this one, you have to look at the 1 second. How many waves have gone by in 1 second? Well, in this case, we only have a half a wave. So the frequency of this wave is equal to 1/2. But in science, we don't write fractions, we write decimals. So 1/2 as a decimal is 0.5. That's the frequency, 0.5. I think that covers all our words that we're working on for this. Those are the definitions that you're going to need. As we start doing some simulations, and if you're online at home, it'll probably be simulations, we're going to be using this vocabulary to do things. It might ask you to find the period, to find the frequency, or to measure the amplitude. You're going to need to use the tools in the simulation to do this, all right? So as we look at a wave, why do we say it's one wavelength? Well, the neat part about this one wavelength is, as we do this, I want you to notice what a wavelength really is. And if I do this right, you can see that a wavelength is nothing but a circle. One up, one down. One up, one down. So a wave is a circle. It keeps repeating. Remember, it's a repeating pattern. It repeats over and over and over again. This is what we're talking about when we look at what a wave is. A wave is nothing more than a circle. All right, and this is for the kids that'll be here. So I'm going to end our broadcast right now. Hope to see you guys soon. Take care of yourselves and stay out of trouble.